we have to talk about coal. So this is the Black Diamond Mines mine shirt on. This is a mine that is in the Northeast Bay. So you may not know that we had coal mining in the Bay Area. That's kind of near Antioch. It was a long time ago. It was really before we built the rail system to get coal from the East Coast or the Midwest, western parts of the country to California, when we had to make our own coal for our needs in the Bay Area at the time. That was a lot of like industry, shipbuilding, heating services, things like that. So it was in the big scheme of things, a relatively short-lived mine. Part of the thing we're going to talk about today is part of the problem is California has just like really terrible coal. It's really low quality. It's really high sulfur. It's not a place where you'd want to mine coal. Just like we kind of see with oil, right? We talk about how California kind of has low quality oil. We have low quality coal too. So it's better to get it from other places when you're thinking about it as an energy resource. I also have my coal earrings in. I know you all are jealous. You wish you had coal jewelry. These are anthracite coal. So we'll talk about the different types of coal. Anthracite is like the highest quality. What does that mean? It means it's the highest energy density. So when we're thinking about how much energy can we get per pound of coal, per ton of coal, anthracite. We don't use anthracite for energy generation generally. We use it for high quality heat purposes. So think steel production, things like that, because it can provide a higher heat for the coal. Okay, so fun stuff to think about. I already had some people say this was kind of depressing. Yes, coal is the largest contributor to climate change. And so that's one of the things we'll be talking about today. So big picture questions, one of the things that comes up in the United States, you hear about it in our politics a lot, is, what place do the coal communities that we've kind of built our economy on in the past? What is the responsibility to help them transition as we're transitioning away from those kind of fuels? Because often in those communities, that is the job, is coal. And so that's something that hopefully your videos kind of highlighted. Health impacts are huge. So what are our limits and what are we willing to tolerate in terms of the health impacts of coal? And then, of course, just kind of the responsibility, as Kirsten talked about in the climate change lecture, coal powered the Industrial Revolution and led to the development of the United States and Europe and things like that. So in terms of a historical perspective of how much greenhouse gas emissions have been emitted by coal and other energy resources, but primarily coal, what responsibility does the developed world have to help other countries make the transition to cleaner energy, as kind of taken up most of the carbon budget, right, on our planet? Coal is the most carbon intensive and dirtiest fossil fuels. And I make the distinction here between those two things. Carbon intensive, that means that it gives the most CO2 per energy that you're getting out of it. So that's the carbon intensity. That's where it's really a big contributor to greenhouse gas emissions and climate change. Dirtiest means other stuff. So the biggest emitter of things like sulfur, mercury, lead, selenium, both in air pollutants and in water pollution, and then solid waste. So these are things that we don't have when we're burning like natural gas or oil. We're able to take sulfur out of oil, for example. So these are where it's both the most carbon intensive and the dirtiest fossil fuel to think about. So why do we use coal? It's abundant, it's everywhere. We talk about how oil is not really evenly distributed around our planet. Coal is pretty much most places. Most places where we use it, they have some. They might not have the quantity that they want, so we do have some, trade of coal, but there's a lot. It is not like a limited resource like we might see for some of our other resources. I put relatively low private costs. We've already talked about how that doesn't take into social costs, but that's one of the drivers and the reason we use coal. It's easy to store. You can have a pile of coal and it's just going to sit there. It's not going to rot. It's not going to degrade. It is just going to be a pile of coal. We've been using it for a long time, so we have a lot of dependence on it, and that's where the politics come in, especially we talked about that a lot in the United States. So we have it. The barriers, the things, the challenges, the things, the reasons we might not want to use coal. We'll talk a lot about the environmental impacts. Those are a lot. And I think it's one of the challenges even when industry is deciding between like natural gas and coal, natural gas really wins out because they don't have to deal with all these other things. Natural gas, we've talked about, has the ability to do combined cycle, which means it can be load following. It can provide a lot more services to the grid. And it doesn't have all this other stuff that we worry about, right? Health and safety, regulations, the ability for them to compete in these wholesale markets with other resources. These are all things that are major challenges to coal, especially here domestically, and why we've really seen a decline in our coal industry. So big picture, coal demand is growing worldwide, but it's been falling in the US since 2007, and it's been falling in Europe since the 80s. So it's really on the decline in the developed world, but still growing in the developing world. So those are the big picture things that hopefully you'll take away from today. We're going to go through significance, what is it, and then we'll finish up with environmental social impacts and the economics. Probably no surprise to anyone, we've already talked about it some in this class, but China is the #1 consumer of coal, followed by India and the United States. So those are really the top 3. China has had a lot of growth, but that's really tailing off. We're not seeing a lot of growth and maybe even a decline in consumption in China. India is still having a lot of growth, and of course, the United States is declining. We talked about it last class, I think. India just came out, it's just coming out with its latest commitments on climate change, and this is the biggest concern, actually, in meeting those goals that they have, is the growth that they're seeing in coal production. All right, you guys have seen something like this before. This is overall energy consumption. Remember, it doesn't include traditional biomass, but coal is #2 after oil in the world, but has fallen to #4 in the United States. It wasn't that long ago that it was really #2 in the United States, and it's fallen to #4 after oil, natural gas, and nuclear. So it's really seen a huge decline in the United States. We mostly use coal for electricity production. So that's why we're talking a lot about it in terms of competition with other electricity generators. You can see that's really definitely true in the United States, but it's really true worldwide as well. The other place we use a lot of coal is in industry, and those places can be even harder to decarbonize places. So if you're thinking about trying to make the whole economy decarbonized, electricity is pretty easy. We have a lot of options. We have solar, we have wind, we have nuclear, we have geothermal. There's a lot of decarbonized options for electricity. It gets harder when you're looking at some of these high heat needs, especially for steel, which actually has coking needs, so in terms of hardening. So it gets trickier. And so we often talk about how some of these are the harder to decarbonize sectors. We need different solutions in order to replace things like coal in those industries. Okay, you've seen this before too. We're thinking about remember we want to think about the whole energy system. What do we want? We want a service that's electricity production. That's why it doesn't really matter where we get it. We just want reliable electricity for our end use. In our coal example, remember this is the main thing we use coal for. Most of the energy losses in this system happen at the power plant. It is, as we talked about electricity generation, it is a heat engine. It's inherent that you have losses here because you're using heat to do work. And so you're putting in, the coal in here, and you're losing 2/3 of it right here. And only 1/3 of it is even continuing on to provide those energy services. So for all of the impacts that we have from coal, this is a pretty lossy system, right? And we're going to talk a lot about the impacts on the upstream part of the coal system. Okay, so let's look at where we are for both the world and the US and where things are going. So I mentioned this is now we're just looking at electricity generation, because remember that's the biggest thing that we use coal for. Coal is about 1/3 of the world's electricity generation, and you can see it's kind of up and to the right still right now, still growing in the world. In the past, much of that growth has been in China. There was a lot of increase kind of in the early 2000s. as they were growing and had growing demand for electricity production. But you can see it's really leveled off a lot in China. India is where we're seeing a lot of the growth, and then the United States and Europe is where it's really declining. So what does it look like in the United States? This is what the pie looks like now. Coal last year provided about 15% of our electricity production. When I was in your seat, which, let's see, that was about right here, it was 50%. And people believed it would be 50% forever because we have so much. And it was viewed to be cheap because we have so much. We can use domestic coal. We don't even have to import it. But you can see the decline with renewables and cheap natural gas. So horizontal drilling, hydraulic fracturing really came into this in terms of us having cheap domestic natural gas, really driving it out. Because like I said, it doesn't compete in all sorts of different ways with combined cycle natural gas when you have just like a coal steam cycle power plant. So it's been declining since about 2007. You can see there's a little bit of ups and downs. A lot of these ups and downs are just demand-based, but the capacity is continuing to decline. So we are continuing to see power plants go off. And we'll talk about the policies and the investment today this administration is trying to reverse this trend. And kind of what people are thinking how effective those policies are going to be. So we'll get to that. Don't worry. Okay. How much coal do we have? We have lots. You guys remember McKelvey, the current ratio, the use to production ratio is about 139 years, but it's kind of always kind of around there. We don't have to look very hard because we know where plenty of coal is. So I would say these are our approved reserves and this is our production, but we haven't looked very hard for approved reserves. Unlike oil, where we've looked really hard to make sure we have it, there's probably a lot more that we could probably economically get, but there's just not demand for it. And so these are probably low estimates in terms of how much coal we could actually economically get out of the ground. This is just what we're doing now. You can see kind of the big places of coal. The United States has plenty. China is the largest producer, mostly for domestic, and you can see India as well. But places like Australia and Indonesia are leaders in exports and are exporting a lot of that coal to Asian markets. So where is the coal in the United States? This is just a map. We'll talk about the different types of coal in a minute, but I give you a map of where coal is located. Most of our production is either in the Appalachian region, think West Virginia, or it's in this Powder River Basin part of Wyoming. Those are kind of our two big producers in the United States. So we have a lot. This is where the reserves are, and this is where the production is. One thing you might notice, Montana has 30% of the recoverable reserves in the United States, but almost no production. And so this is actually a policy decision. So Montana also had a lot of other mining, gold mining, and other things that were pretty detrimental to the ranching, to the environment, things like that. So they put policies in place pretty early on that they didn't want any more mining in the state. And that included coal mining. And so whereas Wyoming has had a lot of coal production kind of from the same area, Montana, because of policies, has virtually no coal mining production. So very just like a state policy, not supportive of that. You can see West Virginia is kind of second, and then a variety of other places that we get coal from. So those are kind of the two big places. Okay, you've seen this before. This is just a model of coal. Just to give you a sense that it's really complicated. Remember, it's a swamp that was squished together. So it's the biomass that settled into the swamp and then was squished over time, temperature, and pressure, right, to make coal. So if you've heard of peat, there are some places like Ireland that use peat as an energy resource. That's like pre-coal. It's like before it got to coal. If you squish it long enough, you get to lignite, and then you get to kind of a higher quality coals over enough time, temperature, pressure. And so 20 meters of plant material will become a 1 meter thick seam of coal. So that gives you a sense of the energy density, right? So if we're talking about biomass versus coal, coal is way more energy dense because you're squishing that biomass together into a rock. let's look at coal. So we talk about coal in kind of two different ways, but one of the ways to think about it is its rank, and that has to do with, they talk about it as a percent carbon, but it's really the energy density of the coal. So peat, like I said, is kind of pre-coal, and then you get into lignite, and then you get into kind of these medium coals, and then anthracite, like my earrings. This is the highest quality coal. And this gives you a sense of what it's used for. So it's kind of these middle ones is mostly what we're using for burning for electricity production, just for that, you know, creating steam in our steam cycle power plants. So what I'm going to pass around, they're labeled 1 through 6, so all the way up to graphite, which would be, we don't burn it, it's not an energy resource, but it would be kind of like here. Graphite is just further kind of squished. Hydrocarbon from our swamps. So you can see all the way from peat to graphite in here. Don't open up these little individual ones, but you should be able to see them pretty well. I took the lid off so you can see these pretty closely. They're different colors too when you have different qualities of coal. Yeah, question, please.
Does it matter what type of coal you use when using it for heating or cooking?
Yeah, it doesn't matter in terms of like you're just getting the heat from it. It doesn't matter which rank it is. It's just going to need more of a lower quality one in order to get that heat that you need. But what it could matter is how much sulfur or mercury or other things that it has in it in terms of the air quality, right? And so, you know, and I'll show you, you know, some places like, you know, like you're talking about, some places people still use it for home heating, home cooking. It's the air pollution that is really the concern. Because it has all of these different contaminants in it. Places like Europe used to use it a lot for building heating. They have, if you go to old buildings, they have like a coal chute basically. They've moved away from a lot of that. And part of that is going to be the air pollution impacts. So that part of the quality is what really matters. Okay, let's talk about mining. So here I'm just showing a picture of a strip mine in Wyoming. I wanted to give you a sense, this is for the US. This is the latest numbers I have, somewhere over 500 active mines. I put these numbers in here to give you a sense of the size of those mines. So we have over 500 mines, but they vary a lot in size. So the Western coal, where we're doing strip mining like this, we tend to have fewer mines, but get a lot more coal out of each mine because we're strip mining. When you're doing underground mining, you have a lot of mines, but you're getting less coal. It's harder to do underground mining and recover a lot of coal than it is to do strip mining, where you're just basically taking off the upper part of the earth. So what does that look like worldwide? So in the US, we've gone a lot more to open pit mining like we do in Wyoming. Still do quite a bit of underground mining. In the rest of the world, there's also a mix. If you watch some of the videos, they talk about the strip mining growth in India, for example. But there's still a lot of underground mining going on as well. And so you can see most of the world is underground mining, which has a lot more impacts in terms of people, health, safety, stuff like that than the strip mining. But the strip mining is going to have a lot more land impact than the underground mining, right? So what do we need to do if we're going to do some coal mining? A lot of this is similar. So I just kind of put a list together to what we do for the oil and gas and things like that, right? You need to have the mineral rights, you need to have permitting, clearing. For surface mining or underground, you're going to be doing some drilling or blasting or something to get away the rock. Even on strip mining, you're usually blasting away the rock that's above the coal seam in order to get down to the coal seam. You have to take care of water and things like that on both sides. Underground mining, you do have to have a lot more monitoring in terms of air quality. So when you get to that coal seam where you just get underground, you have to worry about CO2 emissions, you have to worry about methane emissions, you have to worry about there being enough oxygen. So you have to have a ventilation system, things like that when you're doing underground mining. So a lot of that stuff. In the United States, we require remediation. So for strip mining, you would have to put the rock that you blasted off nicely back. It would be obviously lower than it was originally, but you're supposed to do something to make it kind of look like what it did before you did the strip mining. And then the same thing, they're supposed to do a remediation at underground minings where you make it safe. So you have some sealing opportunities. You want to make sure that there isn't water that's going into the mine, gathering up all those contaminants and putting it into like groundwater and things like that. So there's remediation steps you're supposed to do here. Okay, we've been using coal for a long time. I know there's a lot on this chart. You can go study it if you're interested. Really just give you a sense that we've been using coal for a long time, and we've done a lot of mechanization of it. It used to be very manual labor, but now more and more we're using machines to do it. And I would say even early on, it was manual labor and a lot of child labor, and we'll talk about that in a minute, because kids were smaller and able to get into smaller spaces to get to some of the coal seams. So we no longer allow that in the United States, but in other parts of the world, children are still often used for coal mining. And there's an article in that list talking about Afghanistan, for example, as a place where children are able to get employment or for coal mining. Okay, so what does it look like? Surface mining might be kind of what you think it is. So you can see we have our coal seams here. You have to blast away and dig out the overburden. You extract the coal, and then you kind of put the overburden and the things back. You can get almost all of the coal when doing this. You can see that the seam has to be relatively close to the surface, within 50 meters of the surface for this kind of mining to make sense. So I wanted to give you a sense of scale. So these are pictures from a Wyoming mine. These are the dump trucks that they're using for the coal. You can see people next to it to give you a sense of how big these dump trucks really are. Some of the largest machines we use are for coal mining. There was a video around one called the dragline. This is a strip mine in Wyoming, so that's that same dump truck to give you a sense of scale of how big these mines are. And then these big drag lines, which like I said, there's a video about it. Those are some of the largest machines that we've built, if you don't consider the grid a machine, I guess. And so these move very slowly, and they're lifting up that coal, they're digging it out and putting it into the dump trucks for us to extract it. So really, really large places. And then there's a video in your list about open pit mining in India and how it's impacting communities as well as water quality. But like was mentioned, some people are also going to these places and collecting coal for their own personal use or sale in terms of having an energy resource available to them. So lots of concerns in terms of contamination and air quality impact of using coal for those services. All right, mountaintop removal. This is a way of doing strip mining, but now we're talking more in the Appalachian Mountains in places like West Virginia, where we're removing coal. It's a very controversial practice because basically for this kind of strip mining, you're blasting off the top of a mountain. You're usually putting the top of the mountain into the valley, which usually is streams, so that you worry about water loss and contamination to communities. And then at the end, you don't have mountains anymore. So a really big change to the landscape. So estimates around 500 mountains have been lost in Appalachia due to mountaintop removal. So there's a video about this. My friend Emily Gruber that's worked a lot in this space on water use. This is kind of what it looks like. You're just blasting off the roof. A lot of times for doing these processes, they have to get exemptions from the Clean Water Act federally because of the contamination that they're causing in the valleys and the waterways and the streams. So like I said, a very controversial practice, but still one that's ongoing for coal mining in places like West Virginia. Okay, and then let's talk about underground mining. We'll talk about safety for a minute first. So you may have heard the phrase canary in a coal mine. That's literally what they would do. So canaries tend to be pretty sensitive to low oxygen and contaminants in the air. And so that was like the early warning system. You would take a little caged canary down into the mine with you, and if the canary looks sick or falls over dead, you'd hightail it out of the mine, right? Because this was before they had a lot of good sensors and stuff. Today, like when we would go to black diamond mines and do a tour, you have to wear a little monitor, and they're constantly monitoring the concentrations of oxygen, of CO2, of other things in the mine. So you know if levels drop for some reason, if something cracks, methane comes out into the area and can displace oxygen, or sometimes it's CO2. So this was kind of the early warning system. And then I mentioned, in the early 1900s, we definitely used child labor in our mines. That's no longer allowed in the United States, but is still something that is in practice in other parts of the world. Okay, so what does it look like when we do underground mining? There's kind of two big methods. This is called the room and pillar method, where you're digging out parts of the coal seam, but you're leaving parts of the coal seam to keep the roof up. So you can only collect about 40% of the coal, but you don't have to build supports and worry about the ceiling collapsing on you as much, because you're leaving coal in place to kind of keep the ceiling from collapsing. So that's what kind of this room and pillar looks like. We can use machines now to do a lot of that instead of just people in there carving out the rooms in this. Sometimes you can do something called retreat mining. So when you're done, you've kind of extracted that 40% of that coal seam. You can go to the end and just start taking all of it down, and the roof will collapse and you'll have subsidence on the surface, but you're able to extract more of the coal. So this is, subsidence on the surface is one of the concerns that you have when you have this underground mining, and we see impacts of that in some parts of, like, in the eastern part of the United States. The other way we do it is longwall mining, and you can see longwall mining is more like that, where you're just working from one end to the other to take all of it out. So it's kind of like that retreat mining, but doing it from the get-go. And you can get a lot more of the coal in place, but again, you're probably going to see some surface subsidence. We're seeing a lot more, just like we're seeing kind of in everywhere, a lot more technology with our coal mining, which is making it safer for people working in coal. I had showed you a video in terms of using AI to run the machine, so you don't have to have people down there as often. So from a safety standpoint, as it gets more mechanized and more remote controlled, we do have safer coal mining in places that are implementing those kind of measures. A little bit more context of what's happening in coal production. We just talked about mining and in the United States. Coal production has been declining in the United States along with that coal demand. We don't have a lot of export of coal from the United States. So as demand domestically has declined, production of coal has also declined. And we'll talk about how some of the companies are trying to change that and have export of coal from the United States. But what we've really seen is closing of mines. We've seen a lot of the major US coal companies declaring bankruptcy, including the top three, 1, 2, and 3, kind of in the 2016 to 2019 timeframe, all declared bankruptcy because we were seeing this decline in demand of coal. This is significant in terms of the bankruptcy because of a special provision that coal-fired power plant or coal companies were given in terms of the remediation they're required to do. So a lot of our industries are required to do remediation, whether it's oil industry, you're supposed to cap the oil wells when you're done with them and kind of put it back to the way it sort of looked beforehand. With our nuclear industry, they actually collect money in order to take care of the waste, things like that. The way the coal industry was able to kind of put together the policies on this is they had a policy that was called self-bonding. So what that really means is instead of having to set aside money for the remediation, they basically made the argument they would always be worth enough to be able to pay for the remediation. And so what that meant is as these companies declared bankruptcy, they didn't have the funds to do the remediation. And so the remediation of these mines is left to the state, the local, the federal government, or it just doesn't happen. And it's really because they were required to do the remediation, but they didn't have to set aside the funds to do it. Like we require in other, like for nuclear power plants, we require a decommissioning fund. They have to have that set aside for decommissioning the power plant. The coal industry was able to kind of have this loophole in the policy, so the remediation is really falling to states and communities. There's been a lot, I would say, coal mines and miners really are, I kind of mentioned on our politics, in our media, A lot of these coal mines closed down quickly. Miners were left without pay. They were laid off. They were sometimes given only a couple weeks warning. So there's a lot of obligations that were retirement funds and things like that that weren't met by these coal companies that have gone out of business and declared bankruptcy. I wanted to give you a sense of the scale. So coal mining employment in the United States is somewhere around 50,000 people. Might not seem like a lot of people, but like I said, for local communities, it might be the only job in town. So that's where it makes it really important regionally or locally and not necessarily a big part of our global job mix. And so I kind of just posed this, and there's a video for you guys to watch of like, what is the responsibility? What responsibility does the United States have to these communities because we're transitioning away from coal? So what can we do with these abandoned coal mines that maybe are decommissioned or not? There have been some creative things at looking at, using them for pumped hydro grid storage or gravity storage for those kind of things. So people are trying to be creative. We have these holes in the ground. Can we do things that would support the clean energy transition with these closed mines? Okay, so let's go to upstream and mining. Let's talk about transportation and then a little bit about electricity generation. So this is the way we transport coal domestically in most places is by train. If you've ever seen a coal train, they are long trains of just coal that usually isn't covered. So the challenge can be dust sometimes from the open coal cars because you can get dust off of them. But you have to move a lot of coal around to provide that energy for electricity production. So this is what it kind of looks like, with Wyoming being one of the main places that we're producing coal. This just kind of gives you a sense of the tons of coal by rail that's moving. Most of the coal most of the electricity production in the United States is in the Midwest and the eastern part of the United States. So that's where the coal is being moved to. It's the main transport is rail, like I said, so 120 tons per car, 150 cars per train. And it is still the #1 use of the US railway system, even with that decline. So you can imagine at its peak in 2007, how much of the railway system was really moving coal around for our coal-fired power plants. Looking at international trade, so when we're talking about these different categories, the thermal coal is what we're using for electricity production. The metallurgic coal, that's like our anthracite, that's what we're using for steel. It's very hot, that's that high quality coal. You can see there's been a growth in international trade of especially the thermal coal, especially as places like China and India have really grown in their demand. So the big exporters are places like Australia and Indonesia, followed by Russia in terms of exporting coal. And then the big importers are places like China and India, followed by Japan, Japan has had some ups and downs, but especially after they'd shut off all their nuclear power plants, they kind of had a blip of bringing in more fossil. Japan doesn't have a lot of domestic fossil resources, coal, oil, or natural gas. So if they want fossil resources, they really have to import it. And then just locally. So the Oakland terminal has been fighting a coal exporting terminal in Oakland. I think they just had the last piece of this fight, so they've been fighting it for over a decade, where basically the court has said, yes, this company can move forward with making a coal exporting terminal in Oakland. The way I kind of understand the story from talking to people is Oakland made this agreement with a company. The company didn't specifically mention that they were going to be using coal as one of the things they were exporting. So the city felt like they kind of misled. Once they found out coal was going to be one of them, they wanted to renege on the contract. The judges basically said you have to honor the contract that you made with this company. And so this just is the latest. So they're looking to move forward with exporting coal. So this is one of the ways that some of the companies that are still remaining in the United States are trying to boost production of coal is by exporting it, because there isn't a lot of domestic demand for coal. The big concerns you would have is the coal dust. So often there are open piles of coal when you're doing coal exporting. So rain, wind, things like that will blow coal dust into, you can see surrounding communities are very close by, and of course into the bay. So the environmental and health impacts of having this be a coal exporting terminal are the biggest concerns. Yeah.
Are they not able to cover the containers when transporting coal?
It's just not required. You could cover them and it would just be a little extra effort. So it would be extra time and effort, but a company is not going to do it because it's not required. So we've got the coal, we're moving it to the electricity generation, and then we're making electricity with it. So I'd like to point out, so this is just an example coal-fired power plant in England. We see those cooling towers. Remember, we talked about cooling towers. Remember, we often associate it in our head as with nuclear power, but those really just indicate that it's probably a big power plant because those are major cooling towers. You need a lot of cooling for a big power plant. So this looks like a very large coal-fired power plant. And you know it's coal-fired because you see the stacks. You won't see those stacks at a nuclear power plant. They don't have, exhaust emissions. So this looks like it has 2 steam cycle power plants because you've got 2 boilers, and they probably each are driving their own, basically, steam cycle power plant. So something you can see when you're going around. Okay, so coal, mostly it's going to electricity production. This is just showing you what it looks like for the United States. And as I said, most of that is kind of in the eastern part of the United States, east of the Mississippi. This just gives you a sense, too, of how many coal-fired power plants have shut down and how many are left operating as we've seen this transition happening here domestically. Other things we use coal for, right, is iron and steel, both for heat and for coking or hardening of the iron and steel. There are companies that are trying to work on hydrogen or electrification of these processes, but it is more challenging to make it, especially economically, to have the same kind of high quality steel. But places like Microsoft, for example, has said that they're only going to buy green steel. So companies are kind of driving towards decarbonized steel as one of the things. And then another big industry we use coal for is the cement industry. This is mostly for heat in terms of the coal. So this is an opportunity for using other sources of heat that could be decarbonized. Cement has other CO2 emissions in terms of its aggregate that's not coal related in order to fully decarbonize the cement process. Okay, so that's our coal system. Let's talk about its environmental impacts and then what's going to happen next. So we burn the coal, but obviously not all of that coal becomes energy, right? There's this fly ash or coal ash that's left behind. That's the stuff that's in there that doesn't burn. And so a company has to manage that. For a long time, we didn't have policies domestically about how to manage that. And so what the electricity producer would do would put it into a big pit. Sometimes they would fill it with water. Sometimes they would line it or not. Sometimes it was even just open. Sometimes they would bury it. There wasn't really a policy, but in that coal ash is all of those heavy metals, there's radioactive elements, things like that in there that are bad for humans. So it wasn't until the Obama administration that they actually put in place policies on coal ash. Of course, we've been using coal for a long time, so we have a lot. And they've been having to do remediation back and forth a little bit. One of the things that really brought it, I would say, the public attention was this spill in Tennessee in 2008, where you can see this is coal ash that got washed downstream. So they had it in a big pond. One of the dikes on the pond broke free. The coal ash went into the river. The river, kind of spread it around in the communities, and you can see it was flooding even homes and things like that with coal ash. So huge areas of contamination. So with this, and then with the Obama administration, they were able to finally get some regulations in place for how do we handle coal ash and keep, a lot of times, our waterways safe from it. But as you'll see, a lot of these aren't in place right now. All right, so what are our environmental impacts from our coal system? Remember, there's going to be impacts on all the things we talked about. Upstream when we're doing the mining, midstream when we're transporting the coal, and downstream when we're burning the coal. So all of these places have impacts. And just remember, the overall efficiency of the system is pretty low, especially considering all of these impacts. So let's talk about each of them in place. So upstream, talked about this a little bit, subsidence, worker health, things like that. And then, of course, there are things like water contamination, especially from open mines or tailings of those mines, you can get groundwater contamination of the mercury, lead, things that are in the coal. You also release methane when you open up a coal seam. A lot of methane is usually in the coal seam, and so as you're collecting the coal, the methane is just released to the atmosphere. So it's an additional greenhouse gas that's being released as you're mining for coal. So looking at the methane emissions, this is just showing methane emissions just from the energy sector. So we talked about oil and natural gas already, but you can see we're getting a quarter from coal as well in terms of methane emissions in our energy sector. Yeah.
Is there a difference in methane release between strip mining versus underground mining?
Yeah, so anytime you're opening the seam, if you're doing it underground, you're going to try to circulate that air out and vent it. So you're still releasing the methane to the atmosphere as you've opened up that seam. And of course, strip mining, it's just venting. So it's really hard to collect it when you're opening the coal seam to get the coal out. So it truly is vented with CO2 and other things that you're venting from the seam. Yeah, great question. Fatalities and health impacts that we see in terms of miner safety. The good news is this is looking at it domestically, that we've gotten a lot safer in our coal mining. Fatalities have declined quite a bit. Over time, there's been a lot of regulations and policies to put that in place. But just to give you a sense, the fatality occupant injury rate, so this is per 100,000 workers, is about 20. So you can see we've really declined over time. But there are concerns that right now with the government efficiency, there was a lot of layoffs of the administration that ensures mining safety, that does audits. We do still see companies not meeting all of the regulations for mine safety, but their workforce has really been decimated. And so as there's this effort to increase production of coal in the United States, at the same time that we've kind of gutted this agency, there are concerns about miner safety. So latest data, there was about 10 fatalities for coal mining in 2024. So it's still not zero. And then we were just talking about coal dust from trains. So these are just some pictures from neighborhoods, and you can see kind of the coal dust coming on. So this is, a Raleigh community and other places. This would be a relatively easy thing to remediate, but there aren't any regulations that require coal dust mitigation from our trains. Okay, and then downstream, once we start burning the coal, right? So we can have sulfur, we can have NOx, we can have CO2 emissions from our coal. I'll just put these all up here. Heavy metals, you often hear about mercury or lead coming from coal. That does get into the atmosphere. And then if you're not doing any remediation or scrubbers, like I showed you in the video, then that can get into the local waterways, our lakes and rivers, and then of course into our biologic systems, so into fish and things like that. So much of the mercury in places where you see you're not supposed to eat the fish, or pregnant women aren't supposed to eat the fish because mercury is particularly bad for fetuses, that mercury is likely from coal-fired power plants. And until we got some regulations in place, they were the main source, still are the main source of mercury contamination, for example. Okay, so we talked about it being the most carbon intensive, about 40% of the greenhouse gas emissions for our energy-related greenhouse gas emissions. That does not include the methane emissions. So that's the burning of coal. Major source of sulfur and other contaminants. Back in the 80s and 90s, we really saw impacts from coal-fired power plants. Remember when I was sitting in your seat, that was 2005. It was 50% of our electricity production. So we're using coal for a lot of our electricity production. In the 80s and 90s, what we started to see was major acid rain in the eastern states that were basically downwind of the coal-fired power plants. And so an acid rain policy was put in place. It was actually a cap and trade program that was highly successful because there were technologies that were able to reduce the sulfur emissions that were related to the acid rain. And so you can put a scrubber on a coal-fired power plant and reduce the sulfur emissions downstream of the burning of the coal so that it doesn't produce acid rain. So this is just showing you what that impact looked like. That was melting, like I said, melting statues and buildings and things like that from the acid rain. Of course, it was having impacts on lakes and fish and rivers and things like that. It needed to be a federal policy because we call this cross-state pollution. Like the East Coast, like places like Boston, couldn't tell Ohio to stop emitting sulfur, right? So it needed to be a federal policy in order to have this be a successful policy and reduce acid rain. And you can see the reduction. We really don't worry about acid rain anymore because we've put in place almost all of the coal-fired power plants either use low sulfur coal or they have scrubbers to remove the sulfur from the power plants. So those policies are still in place-ish. We have something called mercury and air toxic standards, or MATS. That's really targeting the arsenic and nickel and mercury and things like that from the coal-fired power plants. And then the acid rain program really became this cross-state air pollution rule. So the same idea, but just further reductions in the sulfur, primarily sulfur, but a little bit of NOx that was impacting other states. Both of these policies have been paused for 2 years. So some of the ways that the Trump administration is trying to revive the coal industry is to make exemptions for some of the air quality requirements, water quality requirements, things like that. And so both of these policies, as of this year, have been paused at least for 2 years. Some of the things we saw with these policies, so with the Clean Air Act and the air quality standards, we really saw this move from being really dominated by coal in West Virginia to coal in Wyoming. So the West Virginia coal is a higher ranking of coal, so it has more energy content, but it's also a higher sulfur coal. And the Wyoming coal, although it's a lower rank, has less sulfur. And so one of the ways coal-fired power plants could reduce their sulfur emissions was just by, well, I'm not going to buy that coal, I'm going to buy this coal that has low sulfur. Other ones had to put in scrubbers in place or run those scrubbers to reduce the sulfur. So we saw that big shift. The mercury one is kind of shifting things back towards West Virginia because the Wyoming coal is a little bit higher mercury, so it depends on how you want to handle that. But of course, all of this is declining. So you can see we saw that kind of growth in Western coal, and then we're just seeing a drop for both Western and Eastern coal as demand has gone down. All right, what do these things do to stuff? I always think this is a pretty dramatic picture. This is a trout that's been deformed by selenium contamination in its river. So that's one of the contaminants we worry about from coal. And that coal ash, and like I said, the first time we actually regulated it was in 2015. Those rules were eased. They were put in place again, and then right now they're like rollbacks. Basically, they're just allowing the states to decide how they want to handle implementing these policies. So what can we do with coal ash? You really want it to be lined. You want to keep it away from water systems because it has all these crazy things in it. You can use it-ish in different things. So for example, you can use it in like concrete. You can use it as a filler in concrete. Y2E2 has a pretty high content of fly ash in the concrete in the building. This building might as well. I'm just more familiar with Y2E2. So you can use it kind of as a filler. It's locking away that carbon. So concrete makes it a pretty stable. You obviously don't want that to come back out because it still has these contaminants in it. But these reuse markets are pretty low. There are a lot of the coal ash. We have a lot of coal ash. So you're creating a ton for every 7 tons of coal that you're burning. And we've been doing that for a long time. So we have a lot of coal ash. These markets are relatively small. So most of it is just having to be contained and kept away from water systems, whether that's landfill or lined pits. So this is kind of just an example of Tennessee Valley Authority who's trying to at least monitor on how they're doing with their coal ash containment. You kind of have to do this continuous monitoring, and you have to think about that a lot of this coal ash stays next to the electricity generation where it was produced, and a lot of those are going to be on rivers because they were using river for their cooling water. And so you worry about contamination of the rivers or groundwater, which is really close to where we're storing this coal ash. So just to give you a big picture, there's a lot of different impacts on our coal system in terms of the environment. There are mitigation things we can do, which we talked about a few things that we can do, but it's still a lot for this whole system. Clean coal, last thing I want to talk about in the environment. It really just means that you're not emitting CO2. There was a big push by the coal industry, this is probably a decade ago now, that they had figured out clean coal. They were really talking about carbon capture and storage, which is just one aspect, right, of all the environmental impacts that we see from coal. But that's what they're referring to when they're referring to clean coal. Okay, I have a couple minutes left, so I do want to talk about the future for our last 2 minutes. You guys have seen this before, so what does it look like in the US for the levelized cost of energy for coal compared to other resources? It's pretty high. And what we're actually seeing is even operating existing coal-fired power plants are higher than things like solar plus batteries, wind plus batteries, or natural gas combined cycle. So in places where there are markets, coal can't compete on the market. So that's a challenge. The cost of the coal itself ranges depending on its energy density and its sulfur content. So those are kind of the two components that you think about in terms of the cost of the coal. So we're seeing retirements. This is what we're looking at in the future for the United States. Capacity has come down. This is kind of the changes to capacity. But the current administration is trying to bolster this industry. And so this is back in April. It was very public announcements. There were several executive orders trying to reduce the environmental restrictions on coal, bolster coal, and in some places just require coal-fired power plants to keep operating past their scheduled retirement date. So we've seen that in some places in Michigan, for example, where the utility doesn't want to keep running the coal-fired power plants, but the administration is basically telling them you need to. So the DOE is getting involved directly. And then most recently, the Trump administration announced $625 million to revive and expand the coal industry. This is just a list of all the different things that that's looking like. This prediction is from May, so this was prior to this announcement. So we don't have what predictions are how this is going to impact things. I see things that this is probably not enough still to revive the coal industry. What we're likely to see is just a delay in the decline rather than growth. We're not really seeing planned installations of new coal-fired power plants in the United States. This is what generation looks like, and then percentage of generation for the United States. We did see this uptick in 2025 in terms of generation from coal, but again, the capacity isn't going back up. So this was really driven by, we saw a spike in natural gas prices, and so some of the coal generation was cheaper than the natural gas. So we did see kind of just like this increase, at least this year, but we'll have to see what's going to happen going forward. Mostly we've seen retirements in the US, we've seen additions in places like China and India for coal capacity. So what is it going to look like in the future? It really depends on country by country policy. China has very young coal-fired power plants that could keep operating for a long time. Ours tend to be more than 50 years old. But what it's going to look like in the future just really depends on what planning looks like for different policies. Okay, that's all I had about coal. If you want to learn more about this topic or other energy topics, visit our Stanford Understand Energy Learning Hub for free resources, including signing up for our monthly Energy Spotlight. Don't forget to subscribe to our YouTube channel and tap the notification bell to be notified for our newest content.